In this video, let us see Poisson equation. So the Poisson equation is dou square u by dou x square plus dou square u by dou y square is equal to f of x comma y. Or we can also write it as del square u is equal to f of x comma y. So this is called as Poisson equation. Now here we are going to see how to solve this type of Poisson equation. That is, here the general formula for Poisson equation is uij is equal to 1 by 4 into ui minus 1 comma j plus ui plus 1 comma j plus ui comma j minus 1 plus ui comma j plus 2 minus h square into f of ih comma jh. So here h represents the interval length. So usually we will be considering the square mesh, so that both along x direction as well as along y direction the interval length is considered to be same. So we can take, instead of k also we are taking it as h here, so that here we are writing h square into f of ih comma jh. Okay, so now to remember this formula, the diagrammatic representation is, if we consider this is the point ui comma j, the adjacent points are, here this will be ui plus 1 comma j, that is we are varying the x coordinate, not the y coordinate. So here this will be ui minus 1 comma j. Similarly, these two adjacent points, that is we have to consider the adjacent points horizontally and vertically. So here if you see this one, here j is fixed, that is I is fixed, j varies. So here it will be ui comma j plus 1, and this will be ui comma j minus 1, right? So these are the points we are representing. And then what about this h square into f of ih comma jh? Based on that h we can substitute the value for h according to the problem. And then here this coordinate point is I comma j. So based on this we have to use this I comma j over here to find out the function value. So here what is the formula is 1 by 4, that is if you want to find out this particular value ui comma j, it is nothing but you have to use the standard 5-point formula, that is average of the adjacent 4 points which lies horizontally and vertically. So that is the formula here, 1 by 4 into, this is ui minus 1 comma j, this is ui plus 1 comma j, and then this is ui comma j minus 1, and this is ui comma j plus 1. So here we have added all these 4 values here. Apart from that we have to subtract the function value at this particular point I comma j. Okay, while doing the problem it will be more clear for you how to use this formula to solve the Poisson equation. Now let us solve the Poisson equation. Del square u is equal to minus 10 into x square plus y square plus 10 over the square mesh bounded by x equal to 0, y equal to 0, x equal to 3, y equal to 3 with u equal to 0 on the boundary by taking mesh length 1 unit. So first, before starting the problem, here we have to first draw a square mesh with the given data. Now let us consider a square mesh. So here this is considered as x-axis, horizontal line is considered as x-axis. So x-axis means y is equal to 0. So this is the line y equal to 0, and this is the line x is equal to 0, that is y-axis here, actually here like this y-axis, and this is x-axis, like this you have to consider this is to be the origin. Now from this x equal to 0, y is equal to 0, and this is the line x equal to 3 because here it is given, and this is the line y is equal to 3. So here why we have splitted this square mesh like this means, here these are the boundary lines, and then it is given that we have to consider the mesh length as 1 unit. So here h takes the value 1. So that by considering h is equal to 1, if you start from the origin 0, this will be 1, this will be unit length 2, and then this is 3. similarly along y direction. Okay, so that is the reason here we have considered a square mesh like this. So now what we have to find out here is we have to find out this intermediate value, that is u1, u2, again here u3, and then u4. So we have to find out these four values. Okay, so before that, what are any other detail given in the question is, here it is given u is equal to 0 on the boundary. So on all the boundary we have to consider u equal to 0. So along this boundary also you have to u equal to 0, u equal to 0, u equal to 0, which means that this is u1 and then u4, which means that here this is 0 0 0 0 0 0 0, that is in all the boundary we have to substitute 0, right? So like this we have to consider. Now we have to move on to the calculation. Value f of x comma y is equal to minus 10 into x square plus y square plus 10. So here since h is equal to 1, here according to the formula we have to substitute h square into ih comma jh, f of ih comma jh. So this is nothing but, since h is equal to 1, it is simply f of I comma j. So we want to find out f of I comma j, where I comma j are the coordinate points. That is, this is 1 comma 1, and this is 2 comma 1, and this is 2 comma 2, this point y2, and this is 1 comma 2. So at these coordinate points we have to find out what is the value of f of I comma j. That is 10 into I square plus j square plus 10. So this is what the function value f of I comma j. So similarly we can calculate these value from f of I comma j. And moreover here, if you notice the function f of I comma j, it is symmetric. That is, the function f of x comma y is equal to minus 10 into x square plus y square plus 10 is symmetric about the line x equal to y. Why it is symmetric about the line x equal to y? Symmetric about x equal to y. That is, if you see, this is the line x equal to y, because if you interchange x and y, there is no change in the function value. So we can say that it is symmetric about x equal to y. So since this is the line x equal to y, this u1 and u4 get coincide. So we can consider u1 and u4 are equal. So it is enough to find, out of four values, it is enough to find u1, u2 and u3 alone. It's enough. So now we are going to write down the formula for u1, u2, u3 alone. Before writing the formula, first let us write down the function value. Function value for u1. u1 means the coordinate point is 1 comma 2. So 1 comma 2 means minus 10 into 1 square plus 2 square plus 10, because I and j are 1 comma 2. So this gives you the value 4 plus 1 5, so minus 150. Similarly for u2 it is 2 comma 2. For 2 comma 2 it is 8 plus 10, so it will be minus 180. Similarly for 1 comma 1 it is minus 120. Similarly for f of 2 comma 1 will be the same as 1 comma 2, so it is minus 150. So now using these values we have to write down the formula for u1 first. So u1 is equal to what? 1 by 4 into, please remember the diagrammatic representation. So the adjacent points are 0 plus 0 plus u2 plus u3 minus of u1 function value is this one. Okay, so it is minus 150. So we have to write it as 1 by 4 into u2 plus u3 plus 150. So this is the formula for u1. Next, let us write the formula for u2. So for u2 it is 1 by 4 into, for u2 it is 0 plus 0 plus u1 plus u4. So u1 plus u4 means both equal to, both are same. So we can write it as simply 2u1 minus function value for u2 is minus 180. So this is equal to 1 by 4 into 2u1 plus 180. Next, similarly, what happened to u3? u3 is equal to again 1 by 4 into, for u3 if you see, adjacent points are u1, u4, 0, 0. So again u1 and u4 are same. So that we can write it as 2u1 minus of minus 120. So this is equal to 1 by 4 into 2u1 plus 120. Okay, so now this you mark it as equation 1, this you mark it as equation 2, and this you mark it as equation 3. Now solving equation 1, 2 and 3, we used to get the answer for u1, u2, u3. That is how to solve this. u2 and u3 are in terms of u1. So you can substitute these equation 2 and 3 in equation 1 in place of u2 and u3. So you'll be getting a single equation in terms of u1. So if you simplify, we'll be getting the value for u1. After getting the value of u1, put it in equation 2, we'll be getting u2, and put it in equation 3, we'll be getting u3. So after solving 1, 2 and 3, first we'll be getting u1, which is equal to 75. Put it in equation u2. So we'll be getting u2 is equal to 82.5. Again you put u1 equal to 75 in equation 3. You'll be getting u3 is equal to 67.5. Again, what about u4? u4 is equal to u1. So that u1 is already 75. So we can write u4 is equal to 75. So like this, we have to solve the Poisson equation using the given formula. Let us see the second question. Solve the Poisson equation. Del square u is equal to 8x square y square over the square mesh with u equal to 0 on the boundary, and dividing the square into 16 subsquares with mesh length 1. So here we have to consider again the square mesh, but we have to consider a square mesh with 16 subsquares by assuming mesh length as 1. Mesh length 1 means we have to consider h is equal to 1. So now we have to consider a mesh like this, which is having 16 subsquares, right? And all the sides are having the boundary values as 0. That is u equal to 0, u equal to 0, u equal to 0, u equal to 0, which means that each point we have to consider, that is here, here, here. Everywhere we have to consider the boundary as 0. Right. Now what we have to find out here, the boundary values are given to be 0. What about the intermediate value? Look at here. This is u1, u2, u3, u4, u5, u6, u7, u8, u9. Right. So we have to find out these 9 values. So before that, let us check the function. So what is the function given here? F of x comma y. What is f of x comma y? 8 into x square y square. Since it is x square y square, for both positive and negative value of x, it is going to be the same, right? And moreover, what happen if we interchange x and y? If you interchange x and y also, there is nothing going to happen. You'll be having the same function. because if it is 8 y square x square is also the same, 8 x square y square is also the same. So we can say that this function is symmetric about x axis, y axis, as well as the line x equal to y. Okay, so here symmetric about x axis and symmetric about y axis means how we can able to apply in this diagram. If we fix the center point u5 as the origin, okay, if we fix this center point as the origin, then only we can apply, we can use the symmetric property about x axis, about y axis. Okay, and also we can use about the symmetric about x equal to y. So now if we apply all these three symmetric property, now if you apply all the three symmetric properties, that is about x axis, symmetric about y axis, and symmetric about x equal to y. Okay, if we use first, let us see symmetric about x equal to y. For symmetric about x equal to y, x equal to y, what is how we can check here about this line, what are the elements getting coincide? u1 will coincide with u9, so u1 will coincide with u9, then u2 u6, and u4 u8. Similarly for x-axis, for x-axis we have to fold this square mesh about the line x-axis, means u1 and u7 will get coincide, u1 equal to u7. Similarly u2 equal to u8. Similarly u3 equal to u9. Similarly we can also write the symmetric property for y-axis. For y-axis we have to fold the mesh vertically, that is u1 will coincide with u3, u4 will coincide with u6, and u7 will be equal to u9, right? So based on all these equality, finally what we can conclude here is u1 is equal to here u3, check all the odd values, u3 is equal to u7, right? Because u1 and u7 are same, u1 and u3 are same, so u3 and u7 is also same. Again, what about u7? u7 is equal to u9. That's it. Similarly, take u2. u2 will be equal to u4, where it is u4 is equal to u8, u4 is equal to u6, and u2 is equal to u6. So u4 equal to u6, which is equal to u8. So from these equations, u2 equal to u4 equal to u6 is equal to u8. Apart from this, we have to find out u5 also. So finally, what we have to find here is, we have to find u1, u2 and u5. So out of 9 values, it's enough to find out 3 values, it's enough. That is u1, u2 and u5 alone. That is u1, u2 and u5. Okay, so for these 3 values alone, it's enough to find out the function value. So what about the coordinate points at u1? At u1, that is u5 is considered to be the origin 0, 0, right? So u2 will be what? 0, 1, right? And u1 will be minus 1, 1. Okay, so first we can consider that point and then we can find out the function value. Now what is the function given here is f of x comma y is equal to 8x square y square. Since h is equal to 1 here, f of ih comma jh is nothing but f of I comma j, which is 8i square into j square. Okay, h square into. So now what happened here is we have to find out the function value for u1, u2, u5. It's enough. For u1, the coordinate point is minus 1 comma 1, right? So that f of minus 1 comma 1 will be 8, because 8 into minus 1 square into 1 square is 8. Similarly for u2 it is 0 comma 1. So f of 0 comma 1 will be 0. Similarly, what is this? u3. u3 the coordinate point is, sorry, u5 the coordinate point is 0 comma 0. For this f of 0 comma 0 is 0 here. So now after finding the function value, now we can write down the formula for u1. As I said, it is 1 by 4 into, what are the adjacent points here? This is u1, u2, u3, u4, u5, u6, u7, u8, u9, right? So now for u1 it is 1 by 4 into u2 plus u4, because the boundaries are 0, so no need to bother about the boundaries. So boundaries are 0, so that we no need to count it here. Anyway, 0 plus u2 is u2. Okay, so u2 directly I am writing here, u2 plus u4 minus the function value. What is the function here? Minus 1 comma 1. So this is equal to what? 1 by 4 into, what is u4 here? u4 is again equal to u2, right? So that we can write 2u2 minus f of minus 1 comma 1 is what? 8. So like this we can write. Similarly u2, what is u2 here? 1 by 4 into u1 plus 0 plus u3 plus u5. u5 minus function value. Function value is what? F of 0 comma 1. So that is, anyway it is 0, already we have found out. So directly we can write it as u1 and u3 are same. So that we can write 2u1 plus u5. That's it. Again u5 we have to write. So 1 by 4 into, it is u4 plus u2 plus u6 plus u8 minus 0. Minus f of 0 comma 0, 0 already. So that here if you want for u, I can write a minus 0 here. So this is equal to 1 by 4 into, actually what do you mean by u2, u4, u6, u8? All the terms are equivalent to u2 itself. So we can write it as 4 times of u2. So 4 get cancelled. So directly we can write u2. So from this what we can conclude here is u1 is equal to u2. Since u5 is equal to u2. So u5 is equal to u2 means it's enough to find out u1 and u2 alone. So now we can simplify this equation 1 and 2, right? Now let us solve equation 1 and 2. So equation 1 we can write 4u1 is equal to 2u2 minus 8. From this is equation 1. From equation 2 we can write 4u2 is equal to 2u1. Again u5 can be replaced as u2. So we can write plus u2. So from this, if you take 2u2 this side, so 4u2 minus u2 is 3u2 is equal to 2u1, right? So multiplying by 2 on both the sides, 6u1 equal to u2 equal to 4u1. Why we are doing this? This 4u1 can be replaced over here. Now you put it in, let it be 3. So in 3 if you put 4u1 can be replaced as 6u2 is equal to 2u2 minus 8. So from this If you take it to this side, finally u2 will be equal to 6 minus 2 4. 4 if you cancel, it will be minus 2. That's it. So u2 is equal to minus 2. Now if you put u2 is equal to minus 2 over here, you will be getting the answer. Right, u2 is equal to minus 2 means here it will be minus 12 is equal to 4u1. So u1 is equal to minus 3. So finally the answer is u1 is equal to minus 3 and u2 is equal to minus 2. So in this particular problem, instead of finding 9 separate values using symmetric property, it is easy to find out 2 values enough.